Hey guys, welcome to my channel and I'm back again with another really interesting premium lead code question video. Today we are going to solve question number 346, moving average from data stream. And from today onwards, I'm going to introduce a small new section in this video where I will also show you the companies that this question has been asked into. So you can see that once you click the company and if you have LeetCode Premium, this question has been asked in Meta, Google, Amazon, Spotify, and in the last 6 months it has also been asked in companies like LinkedIn, Zscaler, Blizzard, etc. So obviously a pretty popular question, guys. You can see has been asked in many companies. So let's get started with the problem statement. First of all, guys, the problem statement says that we are given a stream of integers and a window size. Now what we want to do is to calculate the moving average of all integers in this sliding window. So let's say this is our class, it's called moving average, and this is having a constructor here which is init constructor and which is having this size value here, and this size value initializes the object with the size of the window. And then we have another method here which is called as next. Now next method returns the moving average of the last size values of the string. So basically we have to find, we are given a value number, okay, and what happens is that this value number is inserted into the window, and then this method returns the size values of the string. So let's say if size is k, it is going to find out the average of k values and return that in the response. Now let's also understand it with the help of an example. So you can see here we are given an input moving average next, right? So the first input moving average basically means that this is the initialization. And when it initializes, you can see that we are initializing it with the value 3. That means we always have to find the average value of 3 numbers or 3 most recent number in that window. So the first value that we insert is 1. So because there is only one value, you can see that the average is going to be 1 because we have only single element. Then another 10 is introduced into it. So now we have 2 elements. So the moving average is going to be 1 plus 10 divided by 2, which is 5.5. And then we have 3 here, which is the maximum size of the window. So now you have 3 elements, 1, 10 and 3. So obviously we divided with the maximum size and we get this answer. But once you introduce another element into the window, which is 5, what we have to do is we have to check out the element that was earliest or the first element that was added into the queue. So we check out 1 out of the window and now we have 10, 3 and 5. Again the window is totally full, so we have to divide it by the total size, and you can see that that's how we come to the answer 6.0. Okay, so pretty straightforward example, guys, and this is how the problem statement will look. You can see the constraints are straightforward as well. The size of the window can go from 1 to 1000. The value can go from minus 10 to the power 5 to 10 to the power 5, and at most 10 to the power 4 calls will be made to next. So obviously we have to ensure that the next function is the most optimized as possible. Now let's go into the solution here first of all. Okay, so we know that we have to implement 2 methods, right? Now if you look into the solution approach, first look at the smallest thing that you can solve and always go to the next one a little bit later. So what is the thing that we have to initialize here in this init function? So the first thing that we have to initialize here is the size value, right? So the size value is one thing that we have to initialize. And the other thing which we have to initialize that sort of looks pretty obvious is that to find out the average, we need to have some sort of list where we store all the numbers, right? We have to store all the numbers in that window so we can actually find out the average. So obviously there is going to be a size which is going to be integer, and then we also need a window which is going to be a list of integers. But apart from that, guys, we know that every single time when the next is called, we don't want to go through all our window again and find out the sum of the values divided by the size of the window, and then finally just return the average. So every time we don't want to actually calculate the sum, because we know that there could be a lot of elements inside the window. So what we can also do here is we can have another variable that is called as the window sum. Okay, so we can have this integer value here where we can keep track of the current sum of the window. So let's say when we go to our next element, at every single next move, we will have this window sum being updated with the current sum of the window. Okay, and as soon as the window is full and we know that we have to actually remove the first element from the window, at that point of time we can just subtract the first element of the window from the window sum, and thereby this variable will always be the current sum of the window. Okay, and when we go to our next function, guys, we just have to make sure that all these variables are updated correctly, and in the end we actually return the window sum divided by the window size. So for that, we have to go with a very simple approach. So the first thing first that we want to do whenever we get a next call is we have to update our window with this value, right? So basically append in window, sorry about that. So basically window dot append val. Okay, so now my window is actually having an extra element val into it, and now we have to find out the moving average. But wait, we cannot find the average if the window size is, if the current elements, the number of elements in the window are greater than the window size. But if that is not the case, so let's say if window size is actually less than the maximum size, then we can just return the sum, right? So first thing we did was that we did window dot append val. Other thing that we do was that window sum plus equals to val. That means we append the sum with val. And next we check if the window size, so let's say window size is denoted by size of the window like this, is greater than the actual size, right? So actual size value. If this is, or let's say if this is smaller or equal, right? If this is smaller or equal, that means we don't have to remove any element. We don't have to do any such logic. What we can simply do is just return window sum, because at that point of time we know that the window sum is correct, right? Because we have already appended it. So window sum divided by the size of the window. Okay, now once this thing is done, you can actually store the size of the window somewhere as well. Now once this thing is done, then we know that the base condition is covered. If the window is not having the maximum number of elements over the maximum number of elements, that condition is covered. But in case the window size or the length of the window is actually greater than the size that we currently have, in that situation we have to remove the first element. So what we just do is remove the first element from the window. So let's say the 0th element, we just remove it, and then what we do is that we just subtract the first element of the window from the sum of the window, and then simply we just return the same thing, that is window sum divided by the size of the window. Okay, now in this situation, guys, obviously we have to make sure that we use the right data structure. So if you are using a Python list, we probably have a very small function called as pop, which basically just removes the first element, and it doesn't take it's like a order of one function, and you don't have to worry about its time complexity. But if you are using something like C++ or some other data structure, you have to ensure that you are having either a doubly ended queue like a D queue, so that you have the pointer to the previous and the next pointer, and you are easily able to remove the first element. And what you can do is, to remove the first element, you just make sure that the second element's previous pointer starts pointing to null, and that becomes your head pointer. So it's pretty easy to do if you have a doubly ended queue, but because we are using Python and we already have a pop function, so we don't really have to worry about that. Okay. But that was the approach, guys. So I can actually write that down in the approach as well, that you can maybe use a doubly ended list, linked list, or queue. Okay. So that was the approach. Now guys, that we know how this problem can be solved, let me just write down the code here for you so that you know that this is how it needs to be done. Let me just do that for you, and then we will run that code again. Okay. So this is the code, guys. Let me just go through the code with you once again. So you can see that we use the initialization method to initialize the size, the window, which is the list, and the sum of the window is initially 0. And then we have also defined another function here, which is called as find underscore average, where what we are doing is we are just simply dividing the window sum with the size of the window. And for using the size of the window, Python uses a len function, so we are using length. And then we know that the response has to be in float, so we have to cast the length of the window or the denominator into float, so our actual answer is in float. Okay. So this is my find average function. Let's go into the main meaty function, which is the next. So you can see here that what we have done here is pretty simple. We have just first of all done window.append val, and then we are making sure that the sum of the window is also updated. And now what we are going to check here is that if the window size has actually exceeded the allowed size or not. So you can see if the length of the window is greater than the actual allowed size, then what we do, we actually just simply remove the first element of the window from the window sum, we subtract it. We pop out that element from the window itself. So that's how the first element is actually completely removed from the list. And then we call the find average function. So guys, if this condition is not satisfied, then by calling the find average function, we are just simply satisfying these conditions where window size has not exceeded the maximum size. So find average will simply divide the window sum with the total length of the window. However, if this case is concerned that we have already updated the window sum and the window size, so still this function will work. Okay, let's run this code, guys. Let's see how it works for our test cases, and you can see that it works for the sample test cases, and hopefully it will work for all submissions as well. And you can see that it is pretty fast, beats like 65.26% of the other solutions. Okay. Now that we know about this coding solution, let's go into the time complexity. So obviously, guys, the init function is just initialization function, so its time complexity is going to be constant. Let's go into the next function. So here you can see that the time complexity here is first thing is that we are appending the value into the list, which is constant. We are summing the value into the window sum, which is also constant. And now we're just checking if the length of the window is greater than the size of the window. So I am assuming that this length function can take around order of n. And here we are just comparing the size. And here we are just removing the sum from the first element of the window, which in Python is again constant because it's just fetching the first element. And here the pop function is also constant because we are using here a list, which is, if you're using like Python list, it's a constant function. And then again we are calling a find average function here, where we are again using a length function. So considering that the length function is going to have order of n time complexity to find out all the elements in a list, we can say that this next function could be order of n. However, if we talk about the space complexity, guys, so obviously it is going to be order of n because we are creating a new list which is called as window, but actually it's not completely order of n. It is going to be linear but not completely order of n because the window is going to only have n elements or n plus 1 elements, or basically size elements or size plus 1 elements. So you can see that this is also pretty linear. You can also call it order of n. Okay. So that was the solution, guys. I hope you guys like this solution. I hope you learned something from it. If you did like this video, guys, then please do not forget to like this video and share this video with your friends. If you have any questions, comments, feedback, suggestions for me, please do write down in the comment section below. I would be really happy to address them. And in the end, guys, if you have not yet subscribed to this channel, please do subscribe and hit the bell icon for future notifications of more such programming videos, coding videos, premium videos. Thank you so much for watching. I'll see you guys in the next video, guys. Until then, take care and bye bye.